This is lesson 12.3, Measures of Dispersion. Our objectives are to find the range of a data set, calculate the standard deviation of a data set, interpret measures of dispersion, and calculate coefficient of variation. Measures of dispersion basically measures how spread out the data is. The last lesson, Measures of Central Tendency, tended to look at how the data basically gather around the mean. So this lesson is on how spread out, how far away the data is from the mean or the average. Mean being the middle. So we're going to look at first measure of dispersion is the range. For any data set, the range is given by, you just subtract, it's just the difference between the least value subtracted from the greatest value. So if we have a data set such as, here we have two data sets with the same, let's say they have the same mean, same average, and median is a 7. So just because they have the same mean doesn't mean that they're very close together as far as how they behave. So we check for the measures of dispersion by taking the highest number, 13, and the lowest number, 1, and we can see that 13 minus 1 is 12. So the range in data set A is 12, but in set B, the lowest is 5, the highest is 9, so 9 minus 5 is 4. So we can see that even though they both have the same mean and median, they're very different in how spread out they are. Set A is much more spread out because its range is much larger. So if you were to look at that on a graph, then they would look something more like set A would look more spread out, where this would be the mean, whereas this would be set A, whereas set B the data set would be more closer to the middle or the mean. So even though they have the same mean and median, the range shows that they are very different in how they're spread out. Okay. Standard deviation. Let me let Charity in. Hello, Charity. We're just getting started. We talked about range, where range is the difference between the lowest and the highest numbers. And now we're looking at standard deviation. So standard deviation is another measure of dispersion, or how spread out the data set is. And so basically it's used to show how many deviations, or how far away the data is from the mean or the average. Okay, and so there's a particular method that's involved with that. So the mean, we want to find, I'll do this on the board. So from here, go here. There we go. All right, so in this, for example, in this problem, we want to find the deviations. Find the deviations from the mean. From the mean for all the data values. For all values. And the values are 1, 2, 8, 11, and 13. Okay, so we look at, the first thing we have to do is figure out the mean. So the mean is the sum of all the values over n being the number of values. So this would be x. Okay, so we have to add all these up. So this would be basically sigma means that you're the sum of all values, all x values. So this would be 1 plus 2 plus 8 plus 11 plus 13, and n is the number of data items. So we've got 1, 2, 3, 4, 5. So this would be over 5. So we calculate all that out, and the mean comes out to be 7. So from here, we can look to see how far, so our mean, x bar is our mean, is our symbol for our mean or our average, is 7. So basically what we do here to find our deviation is we subtract x minus our mean. So we look at, so we take 1 minus our 1 is our first value, x, minus our mean, which is 7, and we get negative 6. So the next number is a 2. So this would be 2 minus 7, and we get a negative 5. Next we look at 8. So 8 minus 7, and we get a positive 1. Next is 11. So 11 minus 7, and that's going to give us 4. Next is 13 minus 7, and that gives us a 6. Well, the problem is if you add all these up, okay, you got a negative 6 and a positive 6, so that's 0. So you got 5 and 1, negative 5, and 4 and 1 is a positive 5, so they all add up to 0. So the sum of the deviations always adds up to 0. So we have to do something about that so that we don't always get, we want to be able to measure the standard deviation. So we have to do something about that. Okay, welcome, Strader. So from here, we need to do something else. So let's go back to our PowerPoint notes. So that's what we did. And so we have to come up with a variance. So the variance is found by summing the squares. So basically what we do is we take these numbers and we square them. And then we can add them all up and then divide it by n minus 1. So we take n, which is in this case 5, minus 1, to give us our variance. And this tells us how spread out our data is. Now, the only difference between variance and standard deviation is we take the variance and we apply the square root. And this will tell us how spread out our data is. And standard deviation is a very common way to tell how they're spread out. So this is the formula for standard deviation. Well, it looks pretty complicated, but it's not as bad as it looks once you break it down in the process, and we're going to do that. Okay, so S is the symbol for standard deviation. Some people use SD. This book likes to use S, which is fine. Sigma means the sum. We add up all the deviations. So what we did is we took X minus X bar. Okay, that's what we've done so far. So now we're going to square that number, square each one of those, and then add it up. And then divide by n minus 1, 5 minus 1, and then apply the square root to that. So we're going to take these same numbers, and we're going to do that. All right, so let's see how that works. Okay, so let's go back to our board. All right, so this is X minus X bar. Okay, so that's the first thing we did. So that's our first column. Okay, so I'll put this formula off to the side so we can refer back to it. So this is the sum of X minus our mean squared over n minus 1. Okay, so far we did what was in the parentheses. We did this. So now we want to square that. X minus X bar squared. So we're going to take each one of these numbers and we're going to square them. So this would be negative 6 squared, and we get 36. And negative 5 squared, and we get 25. And 1 squared, and 1 times 1, that's still 1. 4 squared is 16. And then 6 squared, 6 times 6 is 36. So this is our X minus X bar squared. So that's this numerator. So this sigma number symbol means we got to add these up. So this will be here sigma X minus X bar squared. So we add all these numbers up and we get 114. Okay, so this part here is 114. Okay, any questions with that so far? None. Okay, hello Jonathan. All right, now we know that n is the number of data items, right? We counted 1, 2, 3, 4, 5. So n equals 5. So that means n minus 1 is going to be 5 minus 1, which is 4. So we divide that by 4, and we get, so this is divided by n minus 1. And we get, as a number, we get 28.5. So now, to finish this part up, so this is what we've gotten. So far, we've done everything that's inside the radical. So now all we have to do is apply the square root. So 28.5 28.5 square root of that. And that's our standard deviation is square root of the sum of our deviation squared over n minus 1 is this. And so that comes out to be 5.34. And that's our standard deviation. All right, any questions with that? Okay, so that's how we calculate that out. All right, so another thing that we look at for, let me go back to our notes. So these are the steps. Individual steps involving calculations are as follows for standard deviation. Calculate the mean. So we did that first. We find the average by adding up all the numbers, dividing it by n, which is 5, and we got the mean is, or mean average is 7. Okay, find the deviations from the mean, and that's what we did. We subtracted them. Square each deviation, and that's what we did here, x minus x bar parentheses squared. Then we take the sum of the squares, we add them all up, we got 114 divided by n minus 1, which is 4. We've got 28.5, and then we apply the square root. So let's go through that process one more time on the board. Okay, so first thing we have to do is find the mean. We have our data set, 1, 2, 8, 11, 13. We have to find the mean, and that's our sum of all our values divided by n. So we add up 1 plus 2 plus 8 plus 11 plus 13, and we have 1, 2, 3, 4, 5 numbers. So n is 5, and we get 7 for our mean. So now we have to take each item, subtract it, the mean from them. So we take the first number, 1, subtracts minus 7, we got negative 6. Second number is a 2, so 2 minus 7 is a negative 5. 8 is the next one, 8 minus 7 is 1. Next is 11, so it's 11 minus 7 is 4. Next is 13, 13 minus 7 is 6. Problem is, we add all those up, they always zero out. So we have to take, so this is known as our deviation, number of deviations from the mean for each item. So we have to, in order to keep it from zeroing out like this, we have to square it. So this is the deviation squared, and that's x minus x bar, parentheses squared. So we took negative 6, squared it, got 36, and 25, 1, 16, and 36. So we have to take the sum of the deviation squared. So we add all these up, add all these numbers up, and we get 114. Well, we divide that by n minus 1, n being 5, minus 1, we get 4. So it's 14 minus 4, and that's our variance is 28.5. So to get the standard deviation, all we do is we take the variance and we apply the square root, and we get 5.34. Okay, so that's our answer for a standard deviation. Okay, so let's take a look at the next slide. All right, so that goes through the whole process again. They do it a slightly different way than I did. I happen to like the way I did it here a little bit better. It just shows everything. Okay, interpreting measures of dispersion. The main use of dispersion is to compare these sets, and we don't need to do that. Okay, last is the Chebyshev's theorem. And basically, this shows what fraction of the data set is in that standard deviation. For any set of numbers, regardless of how many are distributed, the fraction of them that lie within k standard deviations of the mean. So the formula here is 1 minus 1 over k squared. So every time they give you standard deviation, k is your standard deviation. Okay, so let's take a look at the next problem. What is the minimum percentage of items in a data set which lie within 3 standard deviations of the mean? Okay, so we take 1 minus, since 3 standard deviations is what we're looking at, k would be 3. So we take 1 minus 1 over 3, and we square the 3. We get 1 over 1/9, 1 minus 1 over 9. So if we took 1, so basically, let's look at how that would look on the board. So go to the board. All right, so Chebyshev's theorem is 1, so write this out. Chebyshev's theorem is 1 minus 1 over k squared, where k is the number of standard deviations of their mean. Okay, so in this case, k is 3. So we take 1 minus 1 over 3 squared. And so that's going to be 1 minus 1 over 3 squared is 9, so it'll be 1 over 9. So we need a common denominator, so we can change that 1 to 9 over 9. Well, 9 minus 1 is 8. So our answer is 8 over 9. Well, if you divide that, you get 0.8889, it goes on. So if we move that decimal point over 2 places, we get as a percentage 88.9%. Okay, so that's how much of the data set is within that mean. So if we were to look at a data set, here's the mean. And we're looking at 1, 2, 3 standard deviations, 1, 2, 3 standard deviations. That means that 88% of that data set is within 3 standard deviations of the mean, plus or minus, positive 3 or negative 3. So 88.9% of the data is within 3 standard deviations of the mean. Well, that's kind of standard. But let's see if we're using something that's not so straightforward. What if we wanted to find in the question here, and this is one of the homework problems, find the least possible fraction of numbers in a data set in a data set. Lying within, and I'm not going to use the exact same number as on the homework. So I'm going to use something that's different, 4/5. Okay, so that means 4/5 standard deviations of the mean. Okay, so that means k equals to 4/5. So we use the formula 1 minus 1 over k squared. So we're going to put in here 1 minus 1 over 4/5 parentheses squared. All right. So in your calculator, okay, and so I'm just going to use the other one. Everybody should have the app on their cell phone by now. Okay, you can do this on the calculator. Put in 1 minus 1 divided by, and then here you have to use parentheses, because if you don't, it won't come out right. It'll only square the 4 and not the both of them, and it won't flip it or anything like that. So 4 divided by 5, and then squared. And enter, and we get negative 0.5625. Well, we may want that as a fraction. So you can go to math and hit fraction, the first one, or just hit 1 or just hit enter, and you get 9/6, negative 9/16. And that's your answer. Okay, so that's a couple of examples of using the Chebyshev's theorem. Okay, we're also going to do another example. We're going to do another example with find the standard deviation. All right. So here we have find standard deviation round to one or more places. So we're just going to round it to the nearest tenth. And we have here age. Let me do that. Age and in years, and that's our x. And frequency. Actually, this is our x here. So age is 14, and there's, so 38 people were 14 years old. At age 15, there were 47 people that were 15 years old. 16, 47, 17, 41. There were 41 people that were 17 years old. 18. There were 26 people that were 18 years old. So this is our x. Okay, so we want to find, first thing we have to do is find our mean. So the mean is the sum of all the x values over n. Okay, so we have to add all these up. And so we have 38. Oh, here it is. 38. So we want to find the standard deviation. So with that one, we have 38 plus 47 plus 47 again plus 41 plus 26, and we get 199. 38, 47, 47, 41, 26. Okay, we get 199. Okay, so so we're going to take 14. So this would be, instead of writing it out, 14 plus 14 plus 14, 38 times, and 15 plus 15 plus 15. We're going to take 199. We're going to take each one of these. So 199, that's our n. So we have to take 14 times 38. So to find our sum, we have to multiply each one of these. 14 times 38 plus 15 times 47 plus 16 times 47 plus 17 times 41 plus 18 times 26. I'm going to divide that all by 199. Okay. So we put that on our calculator.
Mr. Jansen?
Yes.
Why is 199 our n and it's not 5?
Well, because this is our frequency. See, instead of writing this out 14, 14, 14, it's because our data set is really 14, 14, 14, 38 times, and then 15, 15, 15, 47 times, 16, 16, 16 times 47, and so on.
Copy.
Okay?
Mm-hmm.
So instead of writing all that out and adding all that up, we can just take 14 times 38, because that's our frequency. Okay? So this will be 14, and then we'll use parentheses 38 times 38, close that, plus 15, parentheses times 47, close that, plus 16, parentheses times 47 again, plus 17, parentheses times 41, and then 8 plus 18 times 26, close that, and let me double check that, make sure my numbers are right. 14 times 38, 15 times 47, 16 times 47, 17 times 41, 18 times 26. Okay, so I hit enter, and I got 3154. So that's the 3154 divided by 199. So we divide that by 199, and we get 15.849. Okay, so basically 15.8. Okay, we get 15.8 is our mean. Okay, 15.8 is our mean, or our average. Okay, question so far. So our mean is 15.8. So now we have to find our deviation, x minus x bar. Okay, we have to find it because our formula, okay, is standard deviation is equal to the square root of our sum of our deviations squared over n minus 1. Okay, so right now we're looking at we're trying to figure out what the parentheses is, x minus x bar, our deviation. And that's what this is here. Okay, so we're trying to figure out, move this over. We're trying to figure out, this was x, so x minus x bar, okay, and so from here we're going to take x is x is actually in the first column, so we're going to take x, which is 14 minus 15.8, and that gives us 14 minus 15.8. We get minus a negative 1.8. So next would be 15 minus 15.8, and that's going to give us a negative 0.8. Next is 16 minus 15.8, that's 15, and we get a positive 0.2. Next is 17 minus 15.8, and we get 1.2. And 18 minus 15.8, and so that's going to be 2.2. Well, if we added all these up, we would get 0. All right, so let's see if we do. We got negative 1.8 plus negative 0.8 plus 0.2 plus 1.2 plus 2.2. Let's see. Minus 15.8 is a negative 0.8. 16 minus 15.8 is 0.2. 17 minus 15.8 is 1.2. 18 minus, yeah, okay. All right, so now we're going to square this. So we take x minus x bar squared. So we take a negative 1.8 and we square that. Negative 1.8 squared. And we get negative 3.24. Next is negative 0.8 squared, and we get negative 0.64. Negative 0.8 squared, and we get negative 0.64. Oh, that should be positive. Now, when you're doing this, you got to make sure that the reason why I got a negative is because I didn't use parentheses. So negative 1.8 in parentheses squared, and that's 3.24. Okay, so and then again parentheses negative 0.8 squared, and we get positive 0.64 rather, and then 0.2 squared is 0.04. 0.04, and then 1.2 squared and we get 1.44. Now, if this cuts out on us, then we'll just use the same Zoom link to come back. All right. 1.44 and 2.2 squared. Squared. And we get 4.84. Okay, so now we take all these and we add them all up. 3.24. So we're going to take all that, and that's going to be the sum of our deviation squared. So this will be 3.24 plus 0.64 plus 0.04 plus 1.44 plus 4.84. So we add all those up, okay? So 3.24 plus 0.64 plus 0.04 plus 1.44 plus 4.84. And just checking that. And we get 10.2. So now we have to divide that by n minus 1. Well, n we said was 199. So this would be 10.2, and so this would be 199 minus 1. So this would be 10.2 over 198. So 10.2 divided by 198, and we get basically 0.05. 0.05. So now all we have to do is apply the square root to get, so this is the variance. So to get the standard deviation, we just take the variance, 0.05, and apply the square root. So we just take this, hit second and square root, and then second and answer. And the answer is the last thing that we came up with on the calculator, and we just hit enter. And we get 0.22. We'll call it 0.23 is our standard deviation. And that's our answer.